In lesson 2.4, we are solving equations. They're going to involve more than one step now, and they actually are going to involve, even though they only involve one variable, you're going to have that same variable occurring in the problem more than once, okay? So they could be, that one variable could be on both sides of the equation. So how do we handle that? Remember that you should never miss an equation. You should always check your work. I am not going to have time in this video to keep it under 15 minutes and show the checks, but you must be checking your work. Please check your equations. There's no reason to miss one. Another thing I want to say is that these equations can be done differently. Some of you may choose a different order of steps from each other. That is okay. But what I'm going to recommend is I always look for where are there more variables. Let me keep the variables on the side of the equation that there's more of. Okay, so that's kind of what I look for first. And the other thing I look for first is there anything I can simplify right now as is without moving things on different sides? Okay, so I would say I actually look for that first. And then the second thing I look for is where should I move the variables to keep them on the side that has more? You don't have to do it that way. The reason I do it that way is because I don't really like working with negatives. It's not that I'm scared of negatives, but I make more mistakes when I work with negatives, so I try to keep everything positive. I recommend that to you as well. So let's look at this first problem. I'm going to do number 1. You're going to try number 2 and 3. I know number 2 looks more challenging, but it's the same thing, just with decimals, okay? So when I look at number 1, the first thing I look at is there anything I can simplify on each side? If I were to, I can't do it on the board, but if I were to cover up this 5n plus 6, if you just ignore that, if you just look at the 7n minus 2, you can't combine those. You can't simplify that. They're not like terms, right? So leave it. Now cover up the 7n minus 2. Look at just the other side of the equal sign. Is there anything you can combine over there? 5n plus 6, they're not like terms. There's nothing we can simplify. But check for that first. In number 3 and 4, we're going to be able to do something there. Or number 4 especially. Okay, so looking at the equation now, I need to decide where I have more variables. We want to isolate those variables to one side of the equation. I have a 7n and I have a 5n. I would typically look at the sign in front of them, but since there's nothing there, remember I can visualize a little plus sign if they're positive numbers. Where do I have more? 7 is definitely more than 5, so I have more on the left. Then I'm going to keep my variable over on the left side of the equation, and I'm going to try to get this 5n to join it, okay? In order to cancel out a 5n, remember we said it's a positive 5n, or we are adding 5n to the 6. I know it seems a little weird, but we want to get that 5n over there. You can't just cross over. There's an equal sign. It's like a barrier. So the only way that 5n is going to get over to the 7n is to use inverse operations. We have a positive 5n, so I would subtract 5n from both sides. Remember, your goal is to cancel it out on the right. So that is how I figured out what to do. The opposite of a positive 5n would be taking away a 5n. Those are going to cancel, and I'm going to combine like terms over here. So right now I have 7n minus 5n. That gives me a 2n. I still have this minus 2, still have the equals, and now I just have a 6 over on the right. Now that equation looks like what you've done in previous lessons, okay? So it's just that initial step. Get your variables together. If they're on opposite sides of the equal sign, you need to use inverse operations to combine them. Now this is a lot easier, okay? I have times by 2 and minus 2. Remember we talked about undoing PEMDAS, so I need to add 2 to both sides. Undo the addition or subtraction first. So I have 2n equals 8, and now I would divide by 2 on both sides. I would end up getting n equals 4. You should check this. So if I plug that into my original equation, I'm going to show the first check, but like I said, I don't have time in this video to do them all. You would put 4 in on both sides. So 7 times 4 minus 2. And we're checking to see, does this equal 5 times 4 plus 6? 7 times 4 is 28. 28 minus 2 is 26. 5 times 4 is 20. 20 plus 6 is 26. So I see that they do, in fact, equal each other. So I want you to try problems 2 and 3. Look at where do you have more variables and keep the variables on that side. Pause, press play whenever you're finished with 2 and 3, and we'll talk about them a little bit. So here's my work for number 2. Clearly I have more variables on this side. 0.7 is a larger decimal than 0.3. So in order to combine that, I do the opposite of this plus 0.3y. I subtract it from both sides, and then I add 0.3 to both sides to get rid of the subtraction, and then I divide by 0.4 to get y by itself. Now I know decimals are a little more work. Remember, when you're dividing decimals, if you don't like working with decimals, you could multiply both the top and the bottom by something to make them whole numbers. Here, really quickly, I would just probably multiply this by 10 and multiply this by 10. As long as you choose the same thing, you're keeping an equivalent fraction. That really just makes this 8 over 4, guys. So what's 8 divided by 4? The answer is 2. Check your work. Make sure your equation and solution are correct. Looking at number 3, I hope you've already tried this one. I would distribute first, okay? You have this 1/2 outside of the parentheses. You need to multiply that by everything on the inside. Now, where do you have more variables? 1/2 or 3/2? We have 1/2 b over here and 3/2 b over here. On the right, there are more. So I would subtract 1/2 b on both sides. And then when I do that, I have 3/2 minus 1/2, which is really 2/2. And you guys know that. Think about that. 2 divided by 2 is really just a 1, but we don't have to write 1b. All right, you can, but I would prefer to really not see that 1b because that's just b. So 2 divided by 2 is just 1. We don't even need to show it, but if we wanted, you could put it right there. And then add 1 to both sides to get b by itself, and we get 4. b equals 4. Check your solution by plugging it back into the original everywhere that you see b, and make sure that it is correct. Let's look at number 4 together. Another one with parentheses. So again, distribute, okay? I always distribute first if I see the parentheses. What are you distributing here? You are distributing everything in front of the parenthesis, but it has to be like right in front of the parenthesis, okay? So you're not distributing this 1, but you're distributing this 5. And what kind of 5 is it? It's actually a -5 or -5. So you are distributing that -5 to both terms inside. So I have 4 minus 6a plus 4a. I'll come back to that in a second. Minus 1. I always distribute first. If I see parentheses, I like to do that as my first step. -5 times 7 is a -35. And a -5 times a minus 2a. Remember, always look to the left of your coefficient of your variable to make sure you see the sign. So it's a negative times a negative. It's a positive 10a. Now look at each side of the equation separately. Can you simplify anything? Over here on the left, if I just look at this side, I can combine like terms. What is a -6a plus a 4a? That would be a -2a. I still have this 4 floating down in front, okay? But I can combine those like terms. Now look on the right side of the equation. Are there any like terms you can combine over there? Yeah, I have a -1 and a -35, so those can be simplified as well. Notice I didn't have to do inverse operations in order to combine these. They're right next to each other, guys. They're already on the same side of the equal sign. You just do it. A -1 and a -35 is a -36. Or a -1, take away 35 is a -36. Okay, so now you need to determine where do you have more variables, -2a or 10a? Definitely the 10a. So I'm going to keep my variable over there. I'm going to move the other one over with it. I would add 2a to both sides in order to cancel it out on the left. When I do that, these cancel and I'm left with just 4 equals negative 36 plus 12a. Now I have to get that negative 36 away from my a. Inverse operations, undo PEMDAS. So undo this minus 36 first. Remember, negative is the same as a minus. And then we'll undo the 12. So the opposite of minus 36 is a plus 36 on both sides. And we get 40 equals 12a. And now I would divide both sides by 12. At this point, you might be a little panicked thinking, wait a second, that doesn't work out to a whole number. My answer must be wrong. Remember that fractions and decimals are numbers as well. 40 divided by 12 can be reduced. Take out a 4, and you're going to have 10 over 3. And that is your answer. The next type of equations are special cases. Okay, so make sure you write this down. You may need to pause. That an identity is an equation that is true for all values of the variable. Take a look at this equation right here. If you have 2 plus x equals x plus 2, you can see that the left side is exactly the same as the right side. So that means every number you put in for x will work. It's like all solutions. All real numbers are your answers. Now, an interesting thing happens in these equations when you solve. If I were trying to get my x's together, I would have a hard time deciding which side to take it to because there's the same amount on both sides. If I subtract x from both sides, I actually end up with no variables. They're both canceled, and I get 2 equals 2. So when you cancel all of your variables, you need to ask yourself, does this make sense? Does 2 equal 2? Is that true or false? This is true, therefore it is an identity, and it is all real numbers as your answer. The other thing that can happen is that when you go and subtract x from both sides, take a look at this next example. If I subtract x from both sides, you could have a false statement, a not true statement. X minus x is 0, x minus x is nothing, and then I have the 3. Does 0 equal 3? No, that doesn't make any sense, right? 0 never equals 3. So this is not true. This is actually false, so that it has no solutions. There is no number that you can put in for x on both sides of the equation that will make this work. So try 5 and 6, pause, and then press play to go over it. So I hope you've tried them. I'm going a little quick due to timing in this video. When I do number 5, I can see that I can combine like terms first, and then when I subtract 3y from both sides, again, the same thing happens as it did up here. Guys, these cancel. Oops, sorry. These variables cancel, and these variables cancel, and what are you left with? You're left with 7 equals 10. When there's no variables left, ask yourself, is this true or false? That is false, therefore it is no solution. And if you wanted to name that type of equation, it's a contradiction. If I look at number 6, combining like terms, and then adding 5x to both sides, I can see that these will cancel, and these will cancel, and I'm left with 11 equals 11. Is that true or false? Well, that's true. 11 always equals 11. Now, that doesn't mean 11 is your answer. It's one of the answers, but in fact, x could be every real number. Okay, so that's important to understand. Okay, reading this word problem, last problem here. It's asking me to find how many hours will John and Sarah have planted the same number of bulbs. So defining my variable, I would define h for the number of hours. I want them to be the same, so I want to know when John's bulbs will equal the amount that Sarah has planted. When I wrote my equation, I knew that John had planted 60 already and is adding to that 44 per hour. Sarah has planted 96 and is adding to that 32 per hour. So your equation should look like that. Try solving it and then look at my work here. When I solve, I get that h is 3. You have to then plug 3 in to your original, to each half really, for John and for Sarah, and double check and make sure you figure out how many bulbs they've planted. They have planted 100